Hey guys, this is Lucas with Better Coding Academy, and in this video I'm going to be introducing you to generators. So I'll be running over a few basic concepts on generators, I'll be explaining how to use them, and I'll be explaining the best scenarios in which to potentially put in a generator. So here I've got two examples that I've put together of generators. Now you'll notice the syntax has the function keyword followed by an asterisk. So this tells JavaScript that you're using a generator. Now in the two generators here, the first one you'll notice has these yield statements, yield 1, 2, and 3, and the second one gets these constants and assigns them to the value of the yield, whatever that means. So we're going to be having a look at both of these examples, and as you can see there's output over here on the right. Actually, I'm just going to put a little break between the two so you know where it starts and ends, if that wasn't clear. And now let's just kind of get into it. So let's look at the basic example of a generator. So firstly, what is a generator? Now, a generator is, in essence, a special type of function, and a generator allows you to produce, basically return more than once inside of your function. That's one way to look at it. But what a generator does is it essentially kind of like an engine of sorts, or like an actual generator, is once it starts running, it spits out values until it completes, if it does complete at all. Now, sometimes generators can go on forever, and I'll show an example of that in just a second. But for example, for this generator here, it returns a total of 3 values, yield 1, 2, and 3. And what we can actually do here is we can actually also return 4. So if we return 4, you'll notice this one becomes value 4 done true. So the difference is if I do yield 4, I get 1, 2, 3, 4 done false, and then I can write gen.next again, and I get undefined done true. So anyways, so what a generator allows us to do is have more than one value kind of be spit out by the function, and normally what that means is that these values can have something in common. So in this case, I'm just obviously showing 4 numbers, but for certain cases you might have information that's related to each step in a process. For example, you might, just as a random example, you might be using what we call a Spigot algorithm. So a Spigot would allow you to generate numbers with relation to a specific value or specific algorithm. So for example, if you have a Spigot algorithm for the number pi, so 3.14 something, and then you have a generator for that, if, assuming you wrote your generator properly, it can keep giving you the digits of pi, and you can keep running the generator. So that's one instance of when a generator would be really useful. There are other instances, for example, if you've heard of the library called Redux Saga. Redux Saga uses generators in order to work kind of alongside Redux, but that's for a separate video. Now let's kind of look at this example and look at it in more detail. So you'll notice that we run the generator here, and what actually happens is surprisingly little happens over here. Notice if I go up here and I write console.log hi, and I'm going to just like get rid of all of this for now. You'll notice I don't even get hi over here after running the generator function, because once you run the generator function like this, nothing actually happens. Only when you run gen.next. So if I do console.log gen, you might be able to see something. You see we have a generator object, and if I do console.log gen.next, what it does is it actually shows hi, and then it gives us value 1 done false. So essentially, a generator, once you first run it like so, nothing happens inside of the generator. But then when you type gen.next, it goes to the first yield statement and runs the code in between. So it runs console log hi, and then yield 1. And what yield 1 does is it gives us this thing over here, which obviously yields the value of 1, and then done being false. Now you don't have to yield a number. You can yield anything like an object or whatever. You can just treat it like some sort of return statement, which gets passed into the value property. So I'm going to keep this at 1. Now, what if we didn't have these 3 here? If we went straight from console log hi to 4, well then we'll get value is 4 and done is true. So done obviously tells you if the generator has anything else to show. For example, if I try to run it again, you'll see we get value undefined done true. And if we keep running it afterwards, obviously we're going to get nothing after that. So I've got gen.next over here, return 4. Now, if I don't run this line, as I said, you won't get hi either, because once you, when you first run the generator, you're not actually running the function. You're just creating a generator from this generator, sort of, if that makes sense. So this is my actual generator, and this function kind of defines how the generator would work, sort of like a class and an object. So you can think of this as like the actual blueprint for the generator, and this one here is the actual instance of said generator. So let's put these statements back. Let's get rid of let's put console log hi here, and let's put console log hey after this one here. Now you'll notice if I only run the first one, I only get hi, and if I run the second one, I get hey. So this is something important as well, which is that this part of the code actually will not run. So this is something to keep in mind if you're using a generator. So one example would be, say, if I had let global value equals, let's just say 1, and then let's just go here and let's comment out this line first. Get rid of console log hey, or actually keep that there, and we'll just change it to global value changed, and we'll write global value is equal to 2. So now if I run gen.next once and I type console log global value, you'll notice that global value gives me 1. But if I run gen.next again, you'll notice that it changes it and now it gives me 2. So that's just something to keep in mind, which is that only this part of the generator runs when you run .next after the first time, and .next goes here, then .next goes here, then it goes here, and it finishes like so. And we get undefined done true, we can get rid of that one. So this is essentially the basic use of a generator. Now let's have a look at a slightly weirder example. So let's go here and let's type while 1. So while 1, this is an infinite loop. Because 1 is always true, and basically if a while loop is true, it'll keep running. So I'm going to write while 1. Now if you had normal function syntax, this will probably break your page. However, by using while 1, if I do yield, and let's just say we yield plus I, and we have an I value here, like let I equal 0, and we add 1 to I, and then we show it, you see we get 1, 2, 3, 4, and if I just keep doing this, you'll notice I keep getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. So this is really cool. Like for example, you can create a generator that generates, maybe powers of 2. For example, get powers of 2, and let's build out this one real quick. So let's just say let current value equal 1, and then we can do current value times equals 2, yield current value like so, and you'll notice what we get is gen.next is 2, and if we just keep printing this out, we get 2, 4, 8, 16, and so on, and this done will never actually become true because this loop runs forever. But like I said, it stops here once it finishes gen.next. So then when you run gen.next again, it basically goes off. It lets it start again, it plays the generator again, resumes it, and it goes here, and then the while loop repeats, it multiplies by 2 again, it yields again, and then it pauses. And once it pauses, once you run gen.next again, then it will play again, it will go here, it will notice it's looping again, and it will just keep going for every single time you run gen.next. So if I can just paste that again, you'll notice that the number just keeps increasing and increasing. So now let's have a look at this example I have down here, which is a generator with arguments. Now I've got const A equals yield 1, const B equals yield A, const C equals yield B, and then yield C. So I've got down here gen2.next A, B, C, D, E, and I'm going to explain basically how this works. So firstly, I want you to notice that we've got the values 1, B, C, D, and undefined over here. So I want you to just notice that for a second and dwell upon that, and then we'll come back here and work things out. So like I said before, this line here doesn't run any of this code. It just creates the generator. But when I do gen2.next A, what happens is it runs from here over to here. Now, when I do gen2.next A, this is really weird because this is something that I don't quite understand. Is what's the point of this argument here in the first .next method? If some of you know, please leave it in the comments or just let me know somehow. But I don't see this A as ever being useful. I don't see how you can take this value, because what you'll notice here is, let's just put in some console logs and let's just write A is, and let's have a look at what A is equal to. So A is equal to B. If I put double quotes on that, and put B here and C here. So let's do C. So let's actually see what A, B, and C are being set to, because we're doing const A equals yield 1, yield A, yield B. And you see A is equal to B, B is equal to C, C is equal to D. So what this means is that this A is getting lost into memory somewhere, not actually sure where this is going. If we can have a look at the arguments of the actual function. So if we do args like that and we console log args like so, you'll notice that the arguments we get are completely empty. Now, if you wanted to put some arguments, you could just do 1, 2, 3 like so, and the arguments go into here like a normal function. So it actually really makes me bewildered as to where this A is going, because the first one, it just seems to disappear. So I'm not really sure what's going on there. But this is how it works, right? Is when I yield 1, what happens is this part of the code runs first. So don't worry about const A, just pretend that const A, this part isn't here. So when you run gen2.nextA, what's happening is it first runs yield 1. So it yields the value out into here, which is why we get, now I need to get rid of all this console log stuff. This is clouding the place up. Is the first thing I get is the value 1, and that's what I get back. Now, once it gets the value back, it pauses here. Now, const A hasn't been set yet, so there is no constant called A. But then when I go to gen2.nextB, when I run it with B, this B gets given back into the yield at this location here. And when it gets given to this location here, what happens is A is then set to B, right? And then what happens is once A is set to B, then it goes on to the next yield statement and it pauses again. So then it yields the value of A, so it yields B out here. And then after that, what happens is it pauses, okay? So B is still not set after this line here. So at this point, B still isn't set. And then we do const B equals yield A. Well, actually, we just yielded A, and then the value that we get back is the one that comes from the next call. So this call here has double quotes C. Now, the C string gets passed in to B, right? Which is kind of weird because the first yield statement and this one correspond, but the B here goes to A, and the C here goes to B, and the D here goes to C. And the E here actually isn't getting used at all, but we'll get to that. So this D here basically gets set to C over here, and then it gets instantly yielded back out here, value D done as false. Now for the last one, we get value undefined done as true for the E. But then if I were to say, for example, do const D equals yield C, and if I wanted to show that in the final output here, I could yield D, but then that would make done equal to false because then you can run it one more time. But if I did return D, you'll notice what happens is it becomes done true. So that's basically how you pass arguments into a generator. So this has just been a video to showcase generators. Now, I said I'd explain basically the use cases of a generator. I've showed obviously the powers. There's also the Spigot algorithm, which is where a single digit gets kind of generated one at a time. I can see generators being useful there. Personally, within website code, I've used generators for breadcrumbs. It's kind of a weird scenario, and I might, if you guys are interested, I might showcase that in a video sometime. But for now, that's generators. It's a new feature in ES 2015 plus. I'm not sure which year it came out, but it's pretty cool. And now it's natively supported in browsers as well. So all of the code I showed today, you can just open up your JavaScript console, or you can download Run.js and just try it out as well. So all of that will work. This has been Lucas with Better Coding Academy, and see you guys later.